Question 4. The halogens are in group 7 of the periodic table. The halogens are all molecules with two atoms joined together by covalent bonds. Complete the sentence to explain covalent bonding. Put a ring around the correct option. The atoms in a covalent bond are held together when electrons are, and then the options are gained, lost, or shared. Well, in a covalent bond, electrons are shared. Electrons are gained or lost when forming ions, so that doesn't happen in just one type of bonding. And then the metallic bonding is where you've got your delocalized electrons holding your cations together. Part 2 says figure 4.1 shows the electron arrangement of a fluorine atom. Complete figure 4.2 to show the dot and cross diagram for F2, show the outer electrons only. So I only need to worry about the electrons that are in the outermost shell, and then I can see that there is one electron here that doesn't have one that is shared. So there are 7 electrons in the outermost shell, which means this atom wants to have an extra electron. So it's going to have to share one electron, and it will have all the rest of its electrons around the outside. So I draw 7 electrons here, and then the other atom also has 7 electrons and wants an extra one, so it's going to have to share one. So I'm going to put them in there. I'm going to use dots, and then I draw the rest around the outside. Now, a good check at the end of doing this is make sure that every single atom you draw has got a full shell at the end. So do we have 8 electrons in our outermost shell in both of the fluorine atoms? Yes, we do. If we've got hydrogen involved, then hydrogen only needs to have 2 electrons in its outermost shell when it has shared the electron, because it's only got one shell. Therefore, there are only 2. 5a says carbon bonds. Question 5. Carbon bonds covalently with more carbons and with other elements to form lots of different compounds. How many covalent bonds does each carbon atom form? We should know this, it's 4, but if we don't know it, we can look at the periodic table and see that it is in group 4, which means it wants to get an extra 4 electrons, so it has to share 4 electrons, and therefore it's going to form 4 bonds. Part 2, which statement explains why carbon can form so many different compounds? So it's a natural element, that doesn't explain it. Lots of elements are natural elements. It's a non-metal, again, that doesn't explain it because lots of non-metals don't form lots of different compounds. It's unreactive, that's definitely not the answer. The answer is that it forms chains and rings with other carbons. So always try and eliminate answers that are wrong, even if you don't necessarily know straight away which answers are correct, and then you can try and take your odds of getting it right and improve those odds. The next part says hydrocarbons are compounds of hydrogen and carbon. Alkanes are one type of hydrocarbon. They have the general formula CnH2n plus 2. Hexane has the formula C6H14. What is its empirical formula? Now, empirical formula is easy to do, but some students find it hard to remember what to do because they forget what empirical means. So empirical, that is the simplest whole number ratio. So I've got C6H14. I can simplify that by dividing both of those numbers by 2, and I get C3H7. Part D says the table gives some information about ethene, polyethene, and diamond. And the first question for that says complete the table. So the type of bonding in ethene is covalent because we've only got non-metal atoms. The type of bonding in diamond is also covalent, which we should know anyway. So here it's because we've got carbon and hydrogen, which are both non-metals. And here we should know carbon, non-metal, all bonded to itself. Ethene, however, is molecular. So it's got this formula C2H4. So it's got a simple molecular structure. For polyethene, it says here it's a large molecule. Can you please annotate in there? It's got a polymer structure. And for diamond, we should know that diamond is giant covalent. Then it says, explain why the melting point of polyethene is higher than the melting point of ethene. Use ideas about chain length and forces between the particles in your answer. So this question is a little bit like a question that you could get in your second exam, but it's also the kind of question you could get in your first exam because we're talking about bonding, structure, and properties. So for the first bit, the polyethene having a higher melting point, and in terms of chain length, polyethene has got a longer chain. Than ethene. And we should know that therefore it's going to have stronger intermolecular forces, because we should know that the intermolecular force strength increases as the chain length increases. In terms of just kind of C2 knowledge, we need to know that both of these substances involve intermolecular forces being broken when they are melted, and therefore when you've got larger substances, they have stronger, so larger particles, in this case the molecules, they have stronger intermolecular forces. So polyethene has a longer chain than ethene, so it has stronger intermolecular forces. And always make sure, if they ever give you a question that asks you to explain why one thing is higher or lower than another, that you use a comparative word in your answer. So longer chain, stronger intermolecular forces. So make sure your answer is comparative. So you can't just say it has a long chain. You have to say how the chain length compares to ethene. Question E says, Umi wants to check the melting point of the polyethene. They have a sample of solid polyethene in a test tube. Describe how they can measure the melting point of the solid ethene. So what we would need to do is use a thermometer to measure the temperature. So measure the temperature. And then we've got to show how we know that it's for the melting point. So when the solid melts. And the key point here is that we're saying the correct change of state, because they're asking about the melting point, they're not asking about the boiling point. So make sure that you read the question carefully and get the correct change of state in your answer. Question 7. Atoms are too small to be seen with the naked eye. Models can be used to help show the size of atoms compared with objects that we can see. What is the typical size of atoms and small molecules? We should know this, it's just a bit of expected knowledge. 1 times 10 to the minus 10 meters. A sphere with a diameter of 2 centimeters is used as a model of an atom. Calculate the diameter of a model of a tennis ball on the same scale. Give your answer in meters and use this formula. So you've got diameter of model atom divided by diameter of a model of a tennis ball is equal to 1 divided by 7 times 10 to the 8. So what we need to do here is we need to, first of all, take our 2 centimeters and we need to convert it into meters. We should know that 100 centimeters is equal to 1 meter. So what we can do then is we can write our known value underneath. What do we do to get from there to there? We divide by 100. So we do the same. And we get 0.02 meters. And then we want to know what's going on here. So use the formula diameter of the model atom divided by diameter of a model of a tennis ball is equal to 1 divided by 7 times 10 to the 8. So I need to put in my model of the atom up here, 0.02, and I'm trying to find the diameter of the model of a tennis ball. So I'm going to do multiplying by 7 times 10 to the 8 on both sides. So I've got my 0.02 over the diameter of the tennis ball times by 7 times 10 to the 8 is equal to 1. Now I want to take my diameter of the tennis ball over, so I multiply on both sides, and I get 0.02 times 7 times 10 to the power of 8, which is equal to 1.4 times 10 to the 7.